Hi, Geometry. I hope you're doing well. I have decided to add a few things to this, so let's see how it goes. This lesson is on solving right triangles. Yeah, I thought I'd spice it up a little bit with that. Okay, so the point of solving right triangles is, well, what does it mean? Well, it means that you're solving for the pieces of the triangle. And to do that, it's really cool. You need, you need a right triangle. And so if you have a right triangle, then you need two sides. You need to know two of the side lengths. How many sides does a triangle have? It has three. So as long as I know two of them, I can solve for the triangle, which means I can find all the other pieces. So I should have said that at the beginning. How many pieces does a triangle have? It has 6. It has 3 sides and 3 angles. And so when we're solving for a triangle, we're finding what those other pieces are. So if they tell us what 2 of the side lengths are, guess what we got to find? 1 other length of a side and 3 angles, because those are the other missing parts from that. If we are given 1 side length and an acute angle, then we got to find 2 other sides and 2 other angles, giving us a total of 6 things. So how do we get an angle measure from 2 side lengths? Great question. So that would be like, we get this triangle. It's a right triangle. It has to be a right triangle for us to use right triangle trigonometry, which are the sine, the cosine, the tangent that we learned in the last lesson. So how do we get an angle measure from this? Well, we're going to talk about this more in depth, but I want to show you a few times because it's very important. So if you have 2 sides, let's say you have this side, let's say it's 10, and then this side is 15. All right. So if we have 2 sides, then you need to use SOHCAHTOA. Remember, SOHCAHTOA. And you need to pick which of these has the sides that are given to us. Now, are we missing something? Yes, we are. What are we missing? We are missing the angle. What angle are we standing at? Remember that when I drew the little stick figure? What is our perspective? Are we here or are we up here? Guess what? You get to choose. All right, so on this, if you were to pick this one, well, if you're standing at this angle, okay, what sides do you know? You know the adjacent side to you, 10, and you know the hypotenuse, being across from the 90-degree angle, it's always the hypotenuse. So you know adjacent and you know hypotenuse. That's cosine. So guess what? Cosine of this theta angle, this angle that you're standing at, is equal to the ratio of the adjacent side over the hypotenuse side. And I'll show you how to solve for cosine. So a few things that we talked about last time was after cosine, after sine, after tangent has to come an angle. You have to have an angle. Okay, and honestly, I'm just holding myself back from hitting this sound effect button because I feel like I'm throwing so many good things at you right now. This is just so full of good information. Anyway, back to it. So picking this perspective or the angle that you're at is what is going to help you pick cosine. Now, let's say your friend over here didn't want to use this angle, and I'll change the color so we can see it, but wanted to choose this angle. Guess what? You could. You just couldn't use cosine because this would be the adjacent side, and you don't know the adjacent side. So what would you use? Sine. You would use sine of that red theta, because what do you know? You know the opposite side over the hypotenuse. So one over the other is not wrong in this case because they both represent the correct sides, the opposite side or the hypotenuse side, and you will get the correct answer for that angle. All right, so moving on, we are going to actually do an example with actual numbers. So you do need your calculator. I hope you have that handy. Otherwise, pause the video, get it, come back. All right, so when we use a calculator to do this, we have to, let's first set it up by saying, okay, what sides do we know? And then we'll put it into our calculator after we pick that. And I have to show you how we do this, because how in the world do we solve for cosine? Oh, so cool. All right, so first off, we look at this triangle, we just observe it. We're not rushing to find the answer. We're just saying, okay, I know 8 and I know 12. Cool. Now, 12, sure, 12 is the hypotenuse. Always going to be the hypotenuse. So either, I'm going to write this at the top. SOHCAHTOA. So if you're using those, well, guess what? You're not going to use tangent because tangent doesn't use the hypotenuse. So tangent's out. Okay, but we could use either sine or cosine. Guess what? Does it matter which one you use? It matters only once you've picked your perspective. Am I standing at this angle down here, or am I standing at this one up here in the corner that I just did 3 marks at? So if you, it depends on what you want to pick. So that's what this is saying. Which of our trig functions relates to those two sides? Well, if you're here, if you're in the blue, can I get the blue? If you're in the blue, then you know, what is that? That's adjacent over hypotenuse. So what relationship is that? Adjacent over hypotenuse is cosine. So you would do cosine of theta. Now again, what if we wanted to stand, and I'll change the color. Let's change it to purple, like this purple. Up here. Well, oh, can you even tell a difference? Make it red. Okay. If you're up there, well, you don't know the adjacent side, you know the opposite side. So you have to use sine. Sine of theta equals the opposite side over the hypotenuse. All right. Hopefully you followed me on all of that. You got that, you're good, and you're ready to move on. So which one do we want to use? Do we want to use the blue one, or do we want to use the red one? Guess what? I'll just do both because I like to. All right, so sine. Let's say we have sine of theta equals the opposite side, 8 over the hypotenuse. 12. I'm still thinking of my last example. Now, in the blue, we've got cosine of theta equals, same thing, 8 over 12. But you'll get different answers because of how we enter this into our calculator. Now, what are we solving for? What is the x? Guys, are you ready for this? The x is the theta. Yeah, that's right. The x is the theta. The x is this angle. How do I get it alone? Because it's the same rules. How do I get the cosine alone? You have to move the sine. You have to move the cosine over to the other side. And here's how you do it. You use what's called the inverse button. So if you look on your calculator, and I got a cool picture here. If you look on your calculator and you see the sine, the cosine, and the tangent button, which is in our first picture that you see, above it, you see those 3 arrows, above it is sine to the -1 exponent, cosine to the -1 exponent, tangent to the -1 exponent. That's the inverse. Now, this is kind of deep. This is kind of like an honors thing, but I just want you to see it because it might help you remember. If not, it doesn't matter. It's not going to affect anything. But think about this. If you want your theta to be alone, you have to do the opposite, right? Cosine is being multiplied to theta. How do I know that? Well, there's not a plus sign. There's not a minus sign. It's right next to it, and that's what we do when we do multiplication, right? If we write 3x, that's multiplication. That's 3 times x. This is cosine times the angle. How do you get rid of something that's being multiplied? You do the opposite. You divide. So if I wanted to divide by cosine, well, that makes sense, but how do you write that? Because what has to come after cosine? Always, always, always. Or after a sine. Always, always, always. Or after a tangent. or any of the other trig functions, which there are more, you have to have an angle. Well, we can't. How can we have an angle when that's the thing we're solving for? So remember back to, I'm about to connect two ideas. Remember back to when you learned the rules for exponents. And if you had something like x to the negative 2, we couldn't leave it like that. You could not leave something with a negative exponent. What did you have to do? You had to make it the reciprocal. What's the reciprocal of this? What's the reciprocal of anything? It's the flipped version of that problem, meaning you flip the numerator with the denominator. Well, the denominator here is 1, so if I flip it, literally like switch their places, now this becomes a positive 2. So the basic rule or the pattern that you see with those is if you move it, you change the sign of the exponent. Only the exponent. The base doesn't change sign. We won't have to deal with that right now. But the exponent is what changes. So I just want to throw this out there and maybe it'll stick. But if you're dividing by cosine, well, that's the same as multiplying by 1 over cosine. That's division of cosine. And, well, I can't have cosine in the denominator. What if I was to, like, move it up? That's cosine to the first. That would be cosine to the negative 1. And that maybe can help you see, like, oh, yeah, that's what that is. But regardless, here's the thing. If solving for an angle, anytime you're solving for an angle, anytime you have the two sides, the hypotenuse and the adjacent, the hypotenuse and the opposite and the adjacent, whatever it is, whenever you have those, but you don't have the angle, you have to use what? The inverse. Now, what is that? That's the negative 1 exponent, negative 1. So back to the picture. This is what you have above your sine, cosine, and tangent button, is that inverse sine, inverse cosine, inverse tangent. That is cosine to the negative 1, sine to the negative 1, tangent to the negative 1. But we just say inverse sine, inverse cosine. I don't know why. Well, I don't really care. So after that, you put the two angles. So you'll see here, they've got cosine of negative 1, the inverse cosine of 8 over 12, which was the relationship we had over here, 8 over 12, right? So you're just writing, okay, theta is going to equal, I've moved the cosine over, of 8 over 12. All right, so it's super fun, super easy to use. Let's see. Oh, yeah, that's what they get. Make sure you're in degree mode because we're finding a degree. Okay, so here are some examples. Inverse sine of 0.5 is theta. So what's theta? So all we're doing right now is practicing putting this in your calculator. So if you hit second sine, that's what gets you above the sine button. So hit second sine and then hit 0.5. And a parenthesis will automatically come up. You can either close it or not. It won't matter in this case because we're not putting anything after that. Hit enter and you get a 30 degrees. So whenever the relationship is half of the sine, so opposite over hypotenuse, it's 30 degrees. Tangent, inverse tangent of 1 equals what angle? Okay, so we'll hit second tangent. That gives us our inverse tangent, 1, and then hit enter. 45 degrees. Okay, ooh, we got inverse cosine. Now, because this is a fraction, I am going to use the parentheses because it's a good habit to get into. I'm going to hit the second x squared button. You have to hit the second button to get, and then x squared, because above that is the square root symbol. Okay, so, sorry, that was gross. So you hit that and you'll have square root 2, and then hit the arrow over button because you don't want to be underneath the radical anymore. You don't want to be under that symbol. And so it should move you out. So hit the arrow to the right. and then it'll be flashing outside of that. Hit divided by, what do we have? 2. Close the parentheses, hit enter, 45 degrees as well. Okay, awesome. So now we've practiced using that. Let's actually do it. Solve the following triangle. Is it a right triangle? Yes, it is. We're in good shape. So let's use our trig functions. So, toa. Okay, now what do we have? We have the case where we're given 2 sides. I'm given a side of 3 and a side of 3. Oh, they're the same. Cool. So 2 sides, they're the same. Maybe you have a thought on this right now. That's cool. If not, no worries. So 2 sides, I've got to find an angle first, right? All right, so what do I know? I know these 2 legs. So let's say I'm at angle A. So angle A, I know the opposite and I know the adjacent. Which of these 3 trig functions only deals with the opposite side and the adjacent side? Tangent. So I can do tangent of A equals opposite 3 over 3. Now that, okay, we're going to solve for A. So we're going to do A equals the inverse tangent of 3 over 3, which is just 1. So you don't have to put the fraction in, you can just put 1. And I think we did that on the last page. It's 45 degrees. A equals 45 degrees. Cool. Now, just to explore this a little further, let's say I'd done B instead. Well, if I'm at this angle, I still only know the opposite and the adjacent side. Okay, cool. So I still have to use tangent. So tangent B is equal to 3 over 3. Wait a minute, that's the exact same thing, except an A and a B. Yes. Oh my goodness, yes it is. Okay, so we move the tangent over. We get B equals inverse tangent of 1, and that's 45 degrees. Again, oh my gosh, right. Remember those special right triangles? And this is what I was thinking maybe you might be remembering, but it's been a while. I mean, we just had 2 weeks off, basically. Where you have the special right triangles, and this is a 45, 45, 90. And remember, these were the same, and they could be whatever. But if those are the same, those angles have to be the same. And so this is a 45, 45, 90 triangle. So you could actually answer this without doing this problem, but we're practicing, we're learning. Just connecting all these dots, little shortcuts. Oh my goodness, I'm not done. So when it means to solve the triangle, it means to find the other sides. Okay, so if this is 45 degrees and this is 45 degrees, great. I know the other angle is 90 because it has to be 90. Now, you could also just find one of the angles, subtract that from 180 and subtract 90 from that, and you'll get the third angle. But what's the third side? What's the hypotenuse going to be? You don't have to do a lot of work if you remember what this relationship is here in this reference triangle. If this is x and this is x, this is x root 2. X times the square root of 2. So if this is 3, this is 3 root 2. That's the hypotenuse. And let's say you forgot. No big deal. Just do the Pythagorean theorem, right? Just use the Pythagorean theorem. It just takes a little bit of time, so it's way easier if you remember the reference triangles. But if you don't, that's cool. 3 squared plus 3 squared equals the hypotenuse squared. I'll just use h squared. Okay, so 9 plus 9 equals h squared. That's 18 equals h squared. Well, that means h equals the square root of 18, which is 2 times 9, and we know 9 is the square root of 9, rather. Because remember, we could write it like this. It's 3 root 2. Boom. So there it is, confirmed, even if you forget. Let's do this one. Oh, not a special right triangle, in case you were thinking, oh, whoa, maybe it's not because it's 42 degrees. It says solve the right triangle, round to the nearest hundredth. Okay, so what do we know? Do we know 2 sides like we have been? No, we know an angle and we know side. Okay, what's the first thing you can solve without having to use like anything super complicated? You can find that other angle. You can find angle Z. How do you do that? You do 180 minus 90 minus 42. Or 90 minus 42. I know this. That's 48, right? Yeah. 90 minus 42 is 48. Okay, so 48 degrees. So this is 48 degrees. Angle Z is 48 degrees. Now, what do we have to solve for? We have to find those other two sides. What side do you know? Keeping in mind, how do we do this? We have to use SOHCAHTOA. All right, so that means, what is this side? Oh, that's the good old hypotenuse. So you're either going to use sine or cosine. Wonderful. So we either use sine or cosine, and it doesn't matter which one you use. If you want to use sine, no big deal. Sine of, let's see, if you're using sine, you need to know the opposite side. So where's your angle? What's opposite? It doesn't really matter. Let's say we're here, sine of x. So this one's opposite. All right, so let's make this x, and we'll make this z since, that's how you name them. It's like smaller, like lowercase, and the angles are uppercase. But sine of 42 degrees equals the opposite side, x, over the hypotenuse, 50. How would you solve for x? Well, it's in the numerator. That's always a positive. So you need to say, oh, it's being divided. I need to do the opposite. I need to multiply by 50. So you'll type into your calculator 50 sine 42. And you just simply type it in. And are we doing the inverse? No, because we're not solving for an angle. You only do that when you're solving for an angle. We have the angles. Now we're going to round to the nearest hundredths. That's 10 hundredths. That's the second place. So that means you look at the third place to see if you round the second one up or not, up or stay. This one's going to move it up. So that's going to equal x, which x equals 33.46. Not degrees. No unit. 33.46. All right. Now let's find little z, the side across from z. So could you use Pythagorean theorem? Yeah. Is that tiresome? Is that like a lot of work? Yeah. Let's save ourselves some time. And let's practice the new thing. So let's see. If I need to know z, you could do so many things. Oh my gosh, so many options. You can either do, instead of sine 42, you could do cosine 42. Why? Because cosine's adjacent z over 50. Same thing. Multiply by 50, goes away. You get z by itself. You put 50 cosine 42 degrees into your calculator. 50 cosine 42 degrees. And I hit something wrong. Enter. And you get 37.16. Gotta round that up. And that's the side length. Okay. So cool. You could have also done like the sine of 48 degrees because that's opposite over hypotenuse. Well, let's see what that is. What's 50 sine 48 as opposed to the 42 we were using? 37.16. Oh my gosh, that's the same thing. So no matter what you choose, still works. That's why I love it. It's so cool. There's options. So maybe you see it a little bit differently than somebody else. Doesn't mean you're wrong. Not at all. So we find all the pieces. Yes, we found two angles and we found two sides. So we're good. All right. Last one. So this one, I want you to do. I don't think there's any tricks in it. Do it. Solve it. Pause the video. Before you do that, pause the video. Solve it. And then unpause it and check your answers with me because I'll I'll keep doing this just in case there's something funky that happens. I don't think so. All right, so at this moment, pause the video. Okay, so hopefully you've unpaused the video because you've solved this problem. I see that I have an angle, so right away I know that I can find the other angle. 53 degrees. I'm sorry. 53 degrees. So we have that. Okay, now I need to know sides. So this, okay, I know this one. You can use you can use any of them that you want. Any of the functions. I'll write it again. So, all right, so let's say I want to use, that's opposite. So let's do sine of 53 degrees, which means I'm standing here at the 53 degree side, or angle. And I'm going to do the opposite over the hypotenuse. You use hypotenuse. So let's say that's little z. And we'll name this one little x while we're at it. So over little z. Oh, yeah. Okay, this is a good one. Because where's our unknown? This is just algebra, basically. Well, it's in the denominator. So I'm going to multiply by z on both sides to move it up, because that's what I'm solving for. So now you got z sine 53 equals 12. Well, I want z to be by itself. So you got to divide by sine 53. My recommendation is to then, that cancels, z equals, and now you're going to go onto your calculator and you can hit 12 divided by parentheses. Put that in parentheses because you want it to stay together. Sometimes it gets messy when there's more things, and if we get in the habit of it, it'll help. Close the parenthesis. Oh, I have to double close? Maybe I don't want to do that. Let's see, that's 15.3. So 0.03 is the length. All right, now let's see if I had done it without. Let's do 12 divided by sine 53 and just hit enter. Same answer. Okay, so maybe we don't want to do that because double parentheses is hard to remember. Yeah, let's go with no. So that's z. Now we got to find x. Well, again, you have so many options. You could use 37 degrees. You could use 53 degrees again. Yeah, you have to use those. You can't use the 90 degrees. You have to use those ones. The two acute angles. So let's say we had, we'll just, for fun, we'll do the other one. 37. So that's sine of 37 degrees equals opposite x over. Oh, cool. I know the hypotenuse now. I know it's 15.03. Now, that's one option. Typically, I don't like using that because it's a rounded number, and I like to be precise. So the 12, I would tend to use that, which means I couldn't use sine, right? If I was doing 37 degrees and I was standing here, I'd have to use opposite over adjacent tangent. Tangent of 37 degrees equals x opposite over 12. This one's set up like the last one where the unknown's above. Then you multiply by that and you hit 12 tangent. Oops. Am I doing the inverse tangent? No. Because when do you do inverse tangent? When you're finding an angle. Enter and you get x equals 9.04. Now, if you had done it over here, you would multiply by 15.03. 15.03. But then you'd have to divide. No, I'm just kidding. You don't. Oh, wow, lovely. You don't have to because your unknown's on the top. All right, so 15.03 sine 37. Oh, same answer. A little bit different in the rounding area because it is, but in the tenths, hundred, thousandths place it's different. But it's still 9.04 when we round to the hundredths place. So that's x, regardless of which way you choose. So you got that and that. And you have everything you need. You have the angle that's missing. You have the two sides that were missing. All right, good job. So I will see you back in the Zoom room.